All right, so now we're going to look at error bar graphs. So we've got our data here, and we're going to go to Graphs Chart Builder. Hit OK. I'm actually going to reset this. Okay, so I can do lots of different types of graphs. It's kind of fun, and you can come in here and you can totally play with that. Okay, so I'm going to do error bar graphs. All right, so I'm going to go to bar. And this is my error bar. I can also do box plots, which are similar, but I'm going to do error bars. So this is going to show me kind of where, how the groups compare visually, right? So I'm going to take this and I'm going to drag it up here. And I'm going to put language in the y-axis, because that's my dependent variable. And then my grouping variable is going to go down here because see groups. So these all represent the different groups. I'm going to make sure that this bar right here, display error bars, is correct. Is collected if I or is selected. If it's not, it's just going to do dots for the data. But this is to show kind of my confidence interval, my 95% confidence interval. I hit OK. And it's going to bring up my data and it's going to look like this. And you can see that there's a difference, right? Like you can see that this group of 20 is way above this one. Whereas there's an overlap between this one and here, and there's an overlap between these two. So that tells me there's no significant difference between these because they overlap, right? There's no significant difference between these because there's an overlap, but there is a significant difference between this and this because they don't overlap. So that's a visual representation of my error bars. And it's a great way to visualize when you're using an Anova to show kind of the differences, right? Okay. So that was that particular assignment all the way through. You did a lot of good work there, right? So now we're going to do another practice. So let's take a look at Chapter 13, data set 2. And this we're looking at swimmers and those who practice less than 15 hours, 15 to 25 hours, and greater than 25 hours. And these will be what the outcome is going to be their time on a 100-yard freestyle dash. So our factor, grouping, or independent variable is the practice time per week. Our outcome, testing, or dependent variable, all the same thing, is time of freestyle. So let's go ahead and grab data set 2. From chapter 13, looks like this. Okay, now we're going to go to analyze, compare means. We're going to go to one-way Anova. Now, which one are we going to put into the factor? What's our grouping factor, right? And if you look at what we wrote here, you'll see that it's practice time. So we're going to put practice time here, and our outcome or testing or dependent variable is time. I'm going to go ahead and run post hoc just in case I need it. And I'm going to hit continue and then options. I'm going to go ahead and run my descriptives just so I have them. And I'll hit, oh, no, I want to estimate effect size, and I'm going to hit OK. All right, that's going to bring up my data. So I just take a look at my descriptives. Looks interesting, kind of a small number, but okay. So check that out, looks good. Look at my source table. And what do I notice about my source table? My source table shows me that I do not have a significant finding, right? This is greater than the 0.05. Because I do not have a significant finding, I will not interpret my effect size and I will not interpret my post hoc because these don't mean anything. And of course, if you look down here, you'll see that none of these are significant either. Okay, and this isn't significant either. This omega random effect is, which is kind of odd, but this would be trash. You can't interpret this unless this is significant. So you have to have a significant result to have a meaningful result. So that's really important to remember. So the only thing I would interpret in this particular study is this right here, saying that there wasn't, there wasn't a significant finding. So I failed to reject my null hypothesis. Okay, and here I have the results. This is what's important. Nothing else matters. This wouldn't matter. This is like trash, right? So my interpretation, the means for the two groups are this, this, and this, and the probability is Here's my F stick, occurring by chance is far above what we expect. Our conclusion, the number of hours of practice made no difference on how you swim. Now, do I think that's true? No, I don't think it's true. But I also had a very small data set. And because I had a small data set, I would not put any value really into that because it was so small. All right, I'm going to put a big X on this so you know we would not interpret that, because this is not significant. So no go. Okay, let's go to practice data set 3. Now, this one we're looking at stress by different groups of employees. Group 1 worked the morning and day shift. Group 2 worked the day evening shift called swing shift, and in group 3 worked the night shift. I've worked all 3 of these shifts, and I can assure you there's a very different level of stress with them. All right, here. We're going to compare our means just like we've done before. Now, what do we notice that's a flag for us? I have 2 scaled, but do I? No, not really. So I'm going to have to cancel, go back out here and say, okay, what's wrong here? This is my scale. This is my stress scale. This one should be a different type of number, right? So what type of number should our grouping number variable be? Nominal. And then I have the values here. So 1 equals the swing shift, 2 equals the midnight shift, and 3 equals the day shift. Hit OK. Now I can run my data. So I'm going to compare means, one-way Anova. I'm going to put shift, which is my grouping variable, into the factor. I'm going to put stress into the dependent means. I'm going to run a post hoc. And I'm going to run a couple of post hocs just so you can see if they look different or if they're very similar. I'm going to hit continue. I'm going to click for our descriptives just so we can take a look at those. And then I'm going to say, hey, go ahead and estimate the effect size if there's a significance, right? Okay, so it's waiting, it's working, it's trying to run the data. Give it a second so it can run the data. It's taking a very long time to run the data. And so, all right, here's our data. So again, we have the swing shift, the midnight shift, and the day shift. This is our data about each one of those, right? Here's our source table, okay? And we're going to look right here. That's an F score of 28.773. We remember that it is significant at the 0.001, not 000. So it's p-value of less than 0.001. And then because I have a significant value, I can take a look at my effect size. I'm going to focus on the eta squared. So I have an effect size of 0.636, which I know is a large effect size for an eta square. Anything over 0.14 is large in eta square. And then I'm going to go down here and look at my pairwise comparisons. Now I've run 3 different post hocs here, and you'll see, look at these numbers. When I go here, they're very much the same. So it doesn't really matter which one you run. This is my favorite, but other people use these. It doesn't matter. You only need to run one, but I wanted to show you they really don't differ. Okay, so let's look at the Tuki. So for Tuki, let's look at the swing shift as compared to the midnight shift. I see this asterisk, so that tells me I have a significant finding. So there is a significant difference in stress between the swing shift and the midnight shift. What about the swing shift to the day shift? Yep. What about the midnight shift to the swing shift? Well, I already determined that, right? And I haven't done midnight today, and that one too is significant. So all of these pairwise comparisons are significant, but I only report 3 of the 6 because the other 3 are just reflections of the first 3. Okay, so then we will go to interpretation. So these are the findings that we had. And then this is telling us how to calculate our degrees of freedom. And here's the interpretation. The amount of stress differs across the 3 groups, my F statistic, my numerator, my denominator. And then here's my F statistic, and it's less than P 0.001. Okay, so again, for my numerator, I do the number of groups minus 1. So that was a 2, right? 3 minus 1 is 2. And then in, I had a total number of 36. So that would be 36 minus 3, which equals 33. Okay, little trick. If I want to know what the sample size was of Anova, I can add these two numbers together and add 1, and I will have my total sample size. So 2 plus 33 equals 35 plus 1 equals 36. Bam. Okay, so you always can determine what the sample size was just from the degrees of freedom. You just need to add a 1 to it. Now let's go to effect size. We've already calculated that in SPSS, but by hand, we would do this. And we would get an eta squared of 0.64, which I know is very large. So it's going to be well above that 0.14. All right, that is my tutorial on Anovas. I hope this has been helpful. Please reach out if you have any questions, and have a wonderful